Let's try another problem. Scientists collect a simple random sample of 25 menthol cigarettes and 25 non-menthol cigarettes. Both samples consist of cigarettes that are filtered, 100 millimeters long, and non-light. The menthol cigarettes have a mean nicotine content of 0.87 milligrams and a standard deviation of 0.24 milligrams. The non-menthol cigarettes have a mean nicotine amount of 0.92 milligrams and a standard deviation of 0.25 milligrams. Use a 0.05 significance level to test the claim that the menthol cigarettes have different amounts of nicotine than the non-menthol. Okay, so let's start with the first group. Our first group that they mention is the 25 menthol cigarettes. So let's talk about group 1, and that's our menthol. So we'll call that M. And let's see what they tell us. Well, first of all, they tell us 25. That means our N1, our sample size for the first group, is 25. They tell us that they have a mean of 0.87. So X bar 1, its mean is 0.87. Its standard deviation is 0.24. So that means the SX1 is 0.24. Let's see, group 2. Group 2 should be our non-menthol cigarettes. So let's talk about group 2. And we'll call that NM, non-menthol. And let's see, the size of that sample, our N2, is also 25. Its mean is 0.92, so its X bar 2 is 0.92. Its standard deviation is 0.25, so its SX2 for the second group is 0.25. Let's see what else they give us in the problem. They also tell us that the significance level we want to use is 0.05. That means our alpha is 0.05. And we're going to test, here's our claim. This is the important part. The claim that the menthol cigarettes have different amounts than the non-menthol. So what this means is that the two means, the mean for the group 1, the menthol, I can use 1 or menthol, M for menthol, and the mean for the non-menthol are different. What symbol do we use for saying that they're different? Well, different means that they're not the same, meaning they're not equal to. So our claim here, we haven't seen this yet, is that the two are not the same. They're not equal to. They're different. So let's take a look at what this means. Because our claim had a not equal to symbol, remember, anything with an equal to lands in the null hypothesis, the H naught. If it has anything that doesn't have an equal to, which includes the not equal to symbol, that means it will land in H1. So our claim, which had the not equal to, landed as our H1. That's what our claim is. So then its opposite, the null hypothesis, would have the equal to. Then we can use this to run our 2-SAMP t-test in our calculator. Remember, we already found out what our group 1 was. It came from the menthol, all the information from the menthol group, which had to do with its mean, which we said was 0.87, its standard deviation, which was 0.24, and the size of the sample for that group was 25. Then we also looked at the non-menthol group, which it had a mean of 0.92, a sample standard deviation of 0.25, and a sample size of 25 as well. So that was our group 1 and our group 2. Then if you continue to arrow down, you needed more information. We also needed to enter in what type of tailed test we're going to be doing, which is always determined by our H1, which we can see has a not equal to. Remember, if it has a not equal to, it's automatically going to run a two-tailed failed test. Remember that we're going to always leave our pooled or not pooled here as no. And then we'll go ahead and tell our calculator to calculate. Remember, it's going to give us two pieces of information. A t, because it's a sample standard deviation that we have. So it's going to give us a t and a p. Okay, so we're given a t and a p. We are only going to use the p-values approach, so I really only care about the p. Remember, though, this p is the area between both of the tails already added up. So this is the area, because this was two tails and both tails combined already. What did they use to make our two tails? Was the first t they used was a negative 0.72, and remember it's symmetric, so they used the same t but positive on the other tail to come up with this area on both ends, and then they just multiply one of the ends by 2 to get the area in both tails. So they did a two-tailed graph automatically. That's what the calculator did for us to find the p-value. After we get the p-value, though, it's the same as what we've done all along, which is p less than or equal to alpha? Well, we just said our p is 0.47, and our alpha was given in our problem of 0.05. Is p less than or equal to alpha? Absolutely not. The question is, what does this mean? Well, I need to rewrite my h naught and my h1 in order to figure that out. Well, my h1 was where I started with my claim, which was that the mean for the menthol was not equal to the mean for the non-menthol, and that was my claim. And that gave me that my null hypothesis was the reverse, which was the equal to. And so what the question is, what does no mean when you say is p less than or equal to alpha? Well, remember that it means no means that you failed to reject h naught. So let's see what that means. If we fail to reject h naught, that means we're going to do the opposite with our h1. We'll still fail to, but we're going to fail to, instead of reject, we're going to fail to, instead of reject, we're going to fail to accept. And the reason why we care about h1 is because that's where our claim is. So we're failing to accept the claim. So there's a typo here. We're going to fail to accept h1. So remember, because we're failing to do something, that means that there is insufficient evidence to do what? We were failing to accept the claim. What was the claim? It was the claim that they were not equal to, or remember that not equal to means that we were claiming that they were different. So there's insufficient evidence to accept that claim. And that's all we needed.